Hi there, fifth grade families. Welcome to this week's edition of Homework Help with your mathematician extraordinaire, Mrs. Bowers. Today is November 13th, so this video is intended to support any homework help that you might need this week. In your homework packet, on the backside of your reading log, you might have noticed that there is a little walk through or a little bit of a guide to help you understand what the homework is asking of you for this week. If that doesn't seem to be doing the job, then you found yourself here. So, welcome to the wonderful world of fractions, in particular, adding and subtracting fractions that have different denominators. So, in fourth grade, you were taught how to add fractions that have the same denominator or like the same unit. So, if we're talking in fourths, 1, 2, 3, 4. I have 2/4 plus one more fourth, and our answer would be 3/4. Okay, you learned that in the fourth grade, and we did do a little bit of that review during our fluency practice the past few days. So, kind of like in video games, I like to use that analogy a lot because y'all play video games. Like in video games, fractions is the same kind of idea. This idea of, you get a basic understanding of how like the game works, and then once you master a level, you move to the next level, which is a little bit of the same, but it's a little more challenging. So we're like taking it up a notch, I guess we could say. So the math that we're doing in fifth grade is more like we're adding or subtracting two fractions that have different units or different denominators. For example, 4/6 plus 1/2. A really big misconception that fifth graders have is they think that they can just add across like they did in fourth grade. They'll add the numerators, 4 plus 1. A lot of fifth graders, slip up and they might add the denominators. 6 plus 2 equals 8. But this is not correct. And the reason why this is not correct, a fraction itself, by definition, is a representation of parts to a total or parts of a total. In order to add them, they have to be the same size, right? Halves are much larger than sixths. So in order to add or subtract, our fractions or our units need to be in the same terms. So in order for this to happen, we actually have to make equivalent fractions. So here's an example that I will kind of talk you through, and then we'll do a little bit of a gradual release into getting you ready for your homework. So let's say, for example, I ate 1/2 of cheese pizza, and then I had 1/4 of pepperoni pizza. Now, the reason why I can't add these is because the units are not the same size. Halves and fourths are not the same size in terms of the fraction. So I have to make them equivalent so that I can easily add these two fractions. There's a few different ways that we can make an equivalent fraction. I typically like to make the larger unit or the larger size. I like to convert it to a smaller size. What I mean by that is halves are bigger than fourths. So I like to convert the halves into fourths. And there's a few ways that you can do this. You can draw a tape diagram or some kind of model, or you can do it numerically using mental math. For my fifth graders who struggle with making equivalent fractions, I might gear them in the direction of using a picture or a model. And for my fifth graders who can do mental math and they can multiply quickly, then numerically is the way to go. But I'm going to show you all ways that we can solve, because my job as a teacher is to give you as many ways or methods as possible, and your job as the learner is to use whatever works best for you. So if I want to convert my halves into fourths, I could draw a picture. If this is one whole, this is 1/2. And I'll even shade it in a little bit. There we go. This is representing 1/2. Since I want to convert it into fourths, what I'll do now is I'll add, let me make that a little bit thicker so we can see it. I'm going to add in a few more units. Now this is in fourths. Now there's 4 equal pieces. So I'm going to take a look at what I shaded in for my halves. I'm going to ask myself, how many fourths are made up of 1/2? Well, that would be 2/4. I just made an equivalent fraction. So when I rewrite my expression, 1/2 is equivalent to 2/4. Then I'll add my other 1/4. 2/4 plus 1/4 is 3/4. Okay? That's one method. That's one strategy. A different way would be to draw a model, which is very similar to the place value chart, or Jesus Louise, to the tape diagram. I apologize. A model looks like this. I'm going to shade in 1/2. I want to convert them into fourths. So I'm going to split this in half. Now I have 4 equal pieces. Well, how many fourths are shaded in? 2/4. So again, 1/2 is equivalent to 2/4. Add 1/4. My answer is 3/4 again. Now, another way we can do this is for my mathematicians who feel more comfortable and confident using mental math. We can solve thinking numerically, okay? So the first step in doing that, and parents and grandparents, this terminology might sound familiar to you. I know it was around when I was in school. That would be the LCM, the least common multiple. So what you'll do is you'll take your units or your denominators, and you'll want to list the multiples of them until you find one that they have in common. So for example, we can list 2, 4, 6, 8, 10, and so on. When I count my multiples of 4, I'm going to stop at the first number that it has in common with the number 2. So if I skip count by 4s, I have 4. Oh, I want to stop right there. I'm stopping here because I have a 4 in common. This 4 now becomes my new denominator. So now both of my fractions will have the same denominator. When I rewrite my fractions, they are both going to have the common denominator of 4. So when I examine or compare my previous fractions, 1/4 will stay the same because that fraction's already in fourths. I'll now use some multiplication to make an equivalent fraction of 1/2. So how this process goes is I'm going to ask myself, how did I get from 2 to 4? Well, I know that 2 times 2 is 4. Whatever you do to the denominator, you have to do to the numerator, which in this case is a 1. I'll multiply 1 times 2, which equals 2. I now have my equivalent fraction of 2/4, which when you add the total, 2/4 plus 1/4 equals 3/4. Yes. Okay. All right, so let's try another example. This time, maybe we can take the example from our homework. Okay. So on our homework, problem number 1 is 3/4 plus 1/8. 3/4 plus 1/8. So the first thing that I'm noticing is that my denominators or my units are not the same. So I have to make them the same. Now, like I just showed you, you can do that either drawing a picture or a model or doing it numerically. Let's take a look at our homework. Our homework already has the models set up for you, and it has it numerically for you as well. So you can use really either or, whatever way is going to get you to what you need to find. So we have 3/4. We need to convert the fourths into eighths. I like going from bigger units to smaller units, like we just did in that previous example. So 3/4 plus 1/8. Here's my model. 1, 2, 3. All right, so here is 1/4, 2/4, and 3/4. I'm going to want to layer on top of that my eighths. So how I'll change my fourths to eighths is just by drawing a line here horizontally. Now I have eighths. How many eighths are shaded in? Here's 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. When I rewrite this, I'm going to want to rewrite my equivalent fraction. 3/4 is equivalent to 6/8. Then I'll add one more eighth to get my answer. We can also solve this numerically using mental math. So I'll take away the model. Excuse me, thank you. You'll notice we get the exact same answer, just without drawing a picture. So I'll find my LCM when I list the multiples of 4 and 8. 4, 8, 12, 16. And I'm going to stop here because I have my number in common, my least common multiple. My least common multiple now becomes the common denominator. They're both in eighths. 1/8 will stay the same, but my fourths need to be changed into eighths. So like we just did in our model, we're going to do the same thinking work, this time using mental math. So I'm going to ask myself, all right, how did I get from fourths to eighths? Well, I know 4 times 2 is 8. Whatever I do to the denominator, I have to do to the numerator. So I'll do 3 times 2 is 6. And then again, I will add my fractions, 6/8 plus 1/8 to get my answer. Okay? So there's a few different ways that we can go about your homework this week. But the most important thing that I want you to take away from this is you cannot add or subtract fractions that don't have like or the same units. You have to find the equivalent fraction first. So this is the reason why last week's homework was all about equivalent fractions. We're really trying to make equivalent fractions. This is also why I have you guys on Reflex every single day. Life will be much easier if you know your multiplication and division facts fluently. It'll make this process a lot faster, a lot smoother for you. Okay, so best of luck. We're going to continue working on equivalent fractions all week this week. So if right now you're feeling like, oh, good, don't worry, it's only Monday. We have a few more days to get more comfortable and more confident with this work. All right, guys, best of luck, and I'll see you in class.